Here we have a situation where we have an object suspended by something that might be a cable from a beam. We know that we model the object as a particle, and we know that particles have all of their mass concentrated at a single point. Throughout the M1 course, our cable would be assumed to be a light, inextensible string. Light means the cable itself has no mass, and you can see if this was a thick steel cable that that would be a poor assumption unless the mass of the particle was so large that we could ignore the mass of the cable. Inextensible means that no matter how much weight is hung on the string, it will not stretch. A beam, or a rod, is usually assumed to be a straight line. It will not bend even with a large weight hung in the middle, as we see here. It will always remain in a straight line, which makes it easier to work with the forces. You could try standing in the middle of a plank supported at both ends to see how good or bad an assumption this is. Clearly real objects bend in the middle if they're supported at both ends and have something heavy in the middle. Our rod or beam may well be light. As was the case when discussing the string, if it is light, it adds no weight of its own into the system. If it has a mass, then the rod or beam could be described as uniform, which means that its weight would be assumed to act at its center, or non-uniform, in which case it may act at some other point along its length.